Welcome to Math World. In this class, let us learn about multiplicative function. A number theoretic function f is said to be multiplicative function if f of mn is equal to f of m into f of n whenever m and n are relatively prime. Whenever GCD of m comma n is 1. A function, number theoretic function f is said to be multiplicative function if f of mn is equal to f of m into f of n whenever GCD of m and n is 1. Multiplicative functions arise naturally in the study of prime factorization of an integer. When we just observe tau and sigma function, say suppose I have tau of 2 into 10, okay, tau 20, tau of 20. How much it is? Tau is nothing but number of positive divisors of 20. So 1, 2, 4, 5 and 5 and 10 and then 20. So there are 6, right? This I can, if I write it like this, tau of 2 into tau of 10, suppose. Then this is tau of 2 is 2 and tau of 10 is 4, which is equal to 8, right? So you can observe that these two are not equal, right? At the same time, if I take sigma of 20, sigma of 2 into 10, that is sigma of 20, sum of the divisors of 20, so it comes out to be 42. And sigma of 2 into sigma of 10, sigma of 2 is 3, 2 plus 1, and sigma of 10 is comes out to be 18, so 54, and they are not equal, right? So it is need not be true that tau of mn is equal to tau of m into tau of n, and sigma mn is equal to sigma m into sigma n. This means it's not necessary that they have to be equal, right? Equality always holds provided we stick to the prime numbers m and n. If m and n are prime, in the sense they are relatively prime, then we can say that tau of mn is equal to tau m into tau n, and sigma mn equal to sigma m into sigma n. If GCD of mn is equal to 1, then fmn equal to f of m into f of n, means f is a multiplicative function. Okay, if suppose if n1 n2 dash dash n are positive integers that are pairwise primes, relatively primes, I mean to say relatively prime, then we can write f of n1 into n2 dash dash nr equal to f of n1 into f of n2 up to f of nr. Okay, if n1, n2, n3 dash dash n are relatively prime in the positive integer which are pairwise relatively prime. If that is the case, then f can be written like this, so that f is a multiplicative function. The big advantage of this multiplicative function is they are completely determined once their values at the prime powers are known to us. Suppose n is greater than 1. N is greater than 1. This value is given to us. Okay. It's a given, in fact, a positive integer. Then we can write the canonical form of n. That means I can write n as product of primes, right? N can be written as product of primes. P1 power k1, P2 power k2 into, say, PR power kr. Since these pi power ki are pairwise relatively prime, in the sense when you take a pair of pi's, they are relatively prime, then we can write f of n as f of p1 power k1 into f of p2 power k2, like that, f of PR power kr. Okay, this is possible when pi's are relatively primes. Here, say I have mentioned n as a positive integer greater than 1. So it can be written in terms of product of primes. That means a canonical form of n. So when this is written, f of n can be written like this. You note one thing, for any multiplicative function not identically 0, multiplicative function identically 0, okay, f of 1 is 1. So this is how, because we can check it out. F of n can be written as f of n into 1. Since f is a multiplicative function, this can be rewritten as f of n into f of 1. Right? Now if we cancel f of n both the side, I'm getting 1 equal to f of 1, in the sense f of 1 equal to 1. So for any multiplicative function which are not identically 0, f of 1 is 1. Now let us prove tau and sigma functions are multiplicative functions. Tau and sigma both are multiplicative functions. So to prove this, when any one of m and n, suppose I have two numbers m and n which are relatively prime, okay, in the sense their GCD is 1. Now among this m and n, if any one is 1, if any one is equal to 1, then the situation is a trivial situation, right? So we are taking m and n which is greater than 1. So the result is true if either m or n is equal to 1. Okay, so I'm just leaving that. I'm assuming that m is greater than 1 and n is greater than 1. Okay, and if I write m in its canonical form like this, m equal to, say, p1 power k1, p2 power k2 into pr power kr. And I'll write n as, say, q1 power j1, q2 power j2, like that, qs power js. These are the prime factorization of m and n. Since it's mentioned that GCD, I'm considering M and N are relatively prime, therefore their GCD is equal to 1. No PI can occur among this QJ, right? Because there is no common factor other than 1 for M and N. Therefore, no PI occurs in the prime factorization of N, or no QI occurs in the prime factorization of M. Okay, so since their GCD is 1, no PI can occur among QJs. Okay, therefore I can write the product Mn, M into N equal to P1 power K1 into P2 power K2 dash dash into PR power KR into Q1 power J1 into Q2 power J2 all the way up to QS to the power JS. Okay, now tau of Mn, M into N equal to C. This is from the formula we know. If M is written like this, it has got a prime factorization like this, then we know the formula tau of M equal to K1 plus 1 into K2 plus 1 all the way up to KR plus 1. That we know. Now here I have written Mn as P1 power K1, P2 power K2 into PR power KR into Q1 power J1 like that till QS power JS. So tau of Mn is equal to K1 plus 1 into K2 plus 1 up to KR plus 1. This is for till here. Then afterwards powers JIs. J1 plus 1, J2 plus 1 up to JS plus 1. Got the point? Now this is same as writing K1 plus 1, K2 plus 1 up to KR plus 1 is nothing but tau of M. And this is nothing but tau of N. Therefore, tau of Mn equal to tau of M into tau of N. So we can say this is tau is multiplicative function. Now let us look at sigma function. Sigma Mn equal to, we know the formula. If M is written like this as a product of primes, then sigma M equal to P1 power K1 plus 1 minus 1 divided by P1 minus 1 into dash 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 up to PR power KR plus 1 divided by PR minus 1. I hope you remember that formula. I have mentioned it in my previous video. So I'll just directly write the values. P1 power K1 plus 1 minus 1 divided by P1 minus 1 into P2 power K2 plus 1 minus 1 divided by P2 minus 1 like that into PR power KR plus 1 minus 1 divided by PR minus 1. This is for this much. Now for this I have to write it Q1 power J1 plus 1 minus 1 divided by Q1 minus 1 into dash 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 QS J power JS plus 1 minus 1 divided by QS minus 1. Okay. So when you look at this first part is nothing but sigma of M and the second part is nothing but sigma of N. Therefore, sigma Mn is equal to sigma M into sigma N. So you can say that the function tau and sigma are multiplicative function provided the choice of m and n, they have to be relatively prime. Then only you can say that the function tau and sigma are multiplicative functions. So just take out one problem. Verify that tau of n equal to tau of n plus 1 equal to tau of n plus 2 equal to tau of n plus 3 holds for n equal to 3655 and 4503. I'll just take up this one. You try by yourself this one. Okay. So I'm taking n equal to 3655. First thing what we have to do is we have to write the canonical form of n. In the sense, I have to write this number in terms of product of primes. Okay, since it's 5, always go for dividing by 5 or try to write this in terms of products of 5 because the last digit is 5 over here. So I'll just write it. Can write it as 5 into 731. I have already done the calculation. I'll just write it down. Okay. So now 731, again I'll try to write it as product of primes. Since its last digit is 1, you try to divide it by 7, 17 like that, or 3, 13, or divide by 9 and all. You check it out, okay, with which number it is completely divisible. Okay, so it can be written as 17 into 43. Okay, now it's written in terms of products of primes. So the powers are 1, 1, 1, right? So we'll calculate tau of 3655. It's nothing but 1 plus 1. You can use any of the formulas. Okay, you can rewrite this as tau of 5 into tau of 17 into tau of 43. Like that also you can write, or you simply take out this powers and write it down. This is 1 plus 1. This is again 1 plus 1 into 1 plus 1. So it comes out to be 2 cube, which is nothing but 8. Okay. You can either write it like this. This is the other way of writing. This you can, since it's written in terms of products of primes, you can just write it like this. Tau of 5 into, tau of 17 into tau of 43. Okay. Tau of 5, it's 2. And this is also 2. This is also 2. So 2 into 2 into 2, which is equal to 8. I'm so sorry. Yeah. This way also you can write, or you can just use the formula and do it. So tau value is 8. That we got. Now what we have to do? We have to verify tau of n equal to tau of n plus 1. N is this. I just have to take n plus 1. N plus 1 is 3656, right? Now I just have to calculate this 3656. For that I have to rewrite this number in terms of products of primes. Say 3656 can be written as, since it's ending with 6, let me divide it by 4 first. I'll write it in terms of products of 4, product of 4. Yeah, 4 can be written as 2 square into 9, 14. Now this 14 again I can divide it by 2, I guess. Yeah, so that it's 457. Yeah. Now you can observe one thing. This is a prime number. So it's written in terms of products of primes now. 2 power 3 into 457. So this is power 3, 3 plus 1 into power 1, so 1 plus 1, so it's 4 into 2 again 8. So 2 of n plus 1 is also 8. Now we'll take n plus 2, it's 3, 6, 5, 7. So I have to calculate 2 of this number. So since it's ending with 7, I'll just divide it by 3 first. So it's 3 into 1219. Then again this is ending with 9, so it should be a multiple of 9 or 3. Okay, yeah, can be written as 23 into 53. Yeah, so I'll just rewrite this as 3 into 23 into 53. Again these two are prime, so powers are 1, so can directly write 2 of 3, 6, 5, 7, 1 plus 1 into 1 plus 1 into 1 plus 1. So it's 2 power 3, which is equal to 8. So you observed one more thing, 2 of n equal to 2 of n plus 1, which is equal to 2 of n plus 2. The last possibility is 2 of n plus 3. It's 3, 6, 5, 8. 2 of 3, 6, 5, 8. 3, 6, 5, 8 can be written as, we'll try to divide it by 4. No, we'll go by dividing it by 2. That could be easier. 1829. Since it's 9 over here, we'll divide it by 3 and check. Okay, this can be written as, this can be written as 2 into 31 into 59. So it's 2 into 31 into 59. So it's again the powers are 1. So 1 plus 1 plus 1 into 1 plus 1. I'm directly using the formula. So 2 cube, which is nothing but 8. So verification is done over here. For n equal to 3655, 2 of n equal to 2 of n plus 1 equal to 2 of n plus 2, which is equal to 2 of n plus 3. Similarly, you try by taking n equal to 4503. Thank you.